Have you ever looked inside a modern train driver's cabin? You'll see a dashboard full of glowing screens, heavy throttle levers, and brake controls. But there is one very obvious thing missing: a steering wheel. If a train weighs thousands of tons, travels at hundreds of miles per hour, and has absolutely no steering wheel, how does it turn? And more importantly, when it comes to a fork in the railway, how does it decide which path to take? Welcome to Simple Things Surprising Histories. Today, we're answering a question you've probably never thought to ask, but will never forget the answer to. How exactly do trains change tracks? To understand how a train changes tracks, we first have to understand how it stays on them. Most people think it's that inner metal lip on the wheel, called the flange, that locks the train to the track and forces it around corners. But that's actually a myth. The real magic is in the shape of the wheel itself. Train wheels are not perfectly flat cylinders. They are conical. They slope slightly downwards from the inside out. When a track curves to the left, centrifugal force pushes the train to the right. Because of that brilliant cone shape, the right wheel suddenly rides on a wider, thicker part of the wheel, while the left wheel rides on a narrower part. This tiny difference in size makes the outer wheel travel a little bit further than the inner wheel, naturally steering the solid axle around the curve. No steering wheel required. It is a masterpiece of passive engineering. So, physics handles the curves, but what happens when the track splits in two? How does the train change lanes? This is where an ingenious piece of track called a switch or a turnout comes into play. If you look closely at a railway junction, you'll see two movable pieces of steel tapering to a very sharp point. These are called the point blades. They are mechanically linked together. When these blades slide to the left, the right blade presses completely flush against the main rail, creating a seamless new path. The train's conical wheel has no choice but to follow this newly formed continuous line of steel. A split second later, the wheel passes over a crisscross section of track called the frog. The frog has a small gap that allows the wheels on the opposite side to safely cross over the intersecting rail. Just like that, the train changes its entire destination. But wait, if the driver isn't turning a wheel, who's actually steering the train? Historically, railway workers called switchmen had to run out and manually pull heavy iron levers to move those point blades. It was backbreaking, dangerous work. Today, the steering is done miles away. Dispatchers sit in high-tech control rooms, monitoring digital maps. With the simple click of a mouse, they send an electrical signal to a motor beside the track, shifting those massive steel point blades in a fraction of a second. The driver's job isn't to steer, but to manage speed, monitor the safety systems, and ensure the train stops exactly when and where it needs to. The track itself does the steering. It's fascinating, isn't it? A massive, roaring machine governed entirely by the simple geometry of a cone and a few shifting pieces of steel. The next time you ride a train and feel it gently glide from one track to another, you'll know exactly the invisible physics and the invisible dispatchers doing all the heavy lifting. Thank you for watching Simple Things Surprising Histories. If you love uncovering the hidden brilliance in everyday things, please hit that like button, share this video with a curious friend, and subscribe to the channel for more. See you next time.